Alright, so a little while back I did a video and I demonstrated how I made a electric choke. This isn't actually a choke because this is a Weber DCOE 45, but it does have a circuit, what you can call a choke circuit. It's actually a rich circuit. So when you're starting the car out, it's like a startup circuit or something. You pull this little lever and it makes the mixture rich, and it makes the car easier to start, and it'll idle for a while, and then after it warms up the idle goes up, and then you turn this off. Now this is, I mean, you can see it has a little connector here for you to put a cable. Well, in this case the cable would have had to loop around and it would have been cabling everywhere, and so I decided that I would put a solenoid in and activate this with the solenoid. You can see the little slide on the solenoid moves back and forth. I made a little piece of linkage and it moves this back and forth. So that was a really great plan. It works really great. It's not a problem except for the human factor. So this is a limited duty solenoid. You can't just leave it on, and if you do it will burn up, and I've burned a second one now. So and the first time I burned it, I was actually driving around and I forgot to turn off the choke. I was like, man, the car is idling a little high. I didn't think anything of it, but after driving it for like an hour, it cooked off, and I remember it was a smelly, smoky mess, and so I replaced it. I was like, oh, no big deal, human error. I won't do that again. And so in my mind, I kept thinking, I'm not going to do that again. Well, this time when I burned it, it was the car wasn't even running. I was just testing this device right here, and I had the ignition turned on, and with the ignition turned on, I had left the switch on during testing, and the car wasn't running, and it just cooked off. So the problem is that this is it's not intended to be just kept on indefinitely. You have to be able to turn it off. Well, there's a human factor, and I want to try to eliminate that. So what we're going to do today is we're going to install a switch with a timer so that we can program it to stay on for like 2 minutes. I think that's what I'll do. I'll set it for 2 minutes, and then it will turn itself off. And then so when you turn the car off, when you turn the car back on again, if the switch is still on, it will turn itself on for 2 minutes and then turn itself back off. So that'll eliminate the human factor from burning up this switch. So what we're going to go through today is some of the wiring. So now this solenoid right here, it runs a little bit more electricity, and so you don't want to have a switch run the high wattage electricity. So we have it set up with a solenoid. There's a lot of different circuits in your car that have solenoids, but typically what you do when you have a solenoid is you want your switch to have a very low wattage. That way your switch won't burn out, and you won't have a lot of electrical current running through the wiring in your dash. So the switch is connected on the bottom of your solenoid, and your power, basically the switch turns on a little solenoid in here which turns on the high wattage power. And then that power runs through to the solenoid. So this relay will activate that solenoid. And so what we're going to do is we're going to add another piece of equipment. I'm going to put it right here, and that little piece of equipment will have a circuit board with a computer chip on it that will turn itself off after a program period of time. So let's go ahead and get started on that. Here you can see I'm 3D printing the box that the little circuit board is going to go in. Got to 3D print everything. That's kind of my gig. Here you can see the char that this has suffered. It was just sitting idle. I mean, the car wasn't even running. It was just sitting with the ignition switch on, but I left this solenoid hot, and it got too hot, and now it won't do anything anymore. So let's go ahead and get this thing cut out and get the new one in. Okay, there we got the new new solenoid in place. Let's just prove that it works. Put the key in the ignition. Okay, you hear the fuel pump doing its thing. And when you hit the switch, you can see the solenoid does its thing. That's the standard mode. And the other thing I had done on this originally to prevent it from being left on and, you know, draining the battery or whatever, is I hooked it up to the ignition circuit. So when I turn it on and then pull the key out, it turns off as well. That was intended to be a fail-safe solution, but it turned out that in that it turned itself off when you turn the ignition off. Then it's out of sight, out of mind, and you forget that the switch is even turned on. The next time you put the ignition on, it's on, and you don't know about it. So let's go ahead and start working on the electrical part of this solution. Now, with a solenoid, you need a low voltage circuit to complete the higher wattage circuit. And so you can see I've run two blue wires. I don't know if you can see that. Yeah. So there's two blue wires here that go to the switch that's installed on the dash in the auxiliary switch position. One of these blue wires, you see it continues and it goes this way, and it's plugged into, well, it's over there, you can see it. It's plugged into the ignition circuit. And this red wire here is also plugged into that circuit, and that's what ultimately feeds power to the solenoid when it's turned on. But the blue is a signal wire, and it needs electricity as well. So this blue wire is going to get cut. And the reason why is the new system doesn't use an electrical switch, it uses a key switch. So basically it's a circuit with inside of the circuit board. So this signal switch from the dash, these two blue wires are now going to become a no voltage switch that's going to complete a circuit on the circuit board. So let's have a look at the wiring diagram so we can explain it just a little bit better. All right, so here's the wiring diagram for that circuit that we're installing. Now you can see that the key switch does not get power directly from the battery. Rather, it gets it through the system. So the blue wire will come into the common and also into this red wire here on the opposite side of the circuit board. So these two wires will get the power, and see this right here will be the blue wire going to the battery. So the positive wires are going to go there. This the negative wire here will go to ground, and the key circuit that goes to the switch at the dash, the two wires that are left over will go to that, and that will activate this starter. Now I am still going to use the relay because I don't know how many watts this device can handle. It doesn't look like it's got a very large wire, so we're going to use this just for the signal wires. And so the outbound wire will be the other blue wire that goes to the relay switch. So instead of this being a motor or whatever, this will be the relay, and it has a ground as well. So that will be how that works. So let's go ahead and have a look at the device and show you the box that we made to mount it. All right, so here's our switch. This is a 12-volt DC. It tells you all the amperage that it allows. And the way this thing works is you have to power this end of it, and this is the switch. So these wires are the switch. The common is right here, and that's where the power will be turned on and off at. And then this is the ground for that part of that circuit. So let's go ahead and do a quick test on this. While I have you here, let me show you, this is the box that we've created for it. You see it has a little tab that meets up with the little holes on the ends. So this will go like this, and then this will slide into the box. See, there's a little slot right here, like that. And this box has little slots right here to receive a zip tie. And the idea behind that is that you may want to make some adjustments later, and you want to be able to take it apart when you need to. So the other thing you might notice on this box is I put a couple of little holes here. These holes are for these LEDs that show you the power and when it's turned on. And so this is a piece of clear PETG, and I just intend on making a little fiber optic indicator that will tell you when the power's on and when it's green. That's the plan anyway. We'll see if that even works. You know, these are LEDs, and this is not really fiber optic cable. This is just a piece of PETG. But we'll see if that works. We'll put that to the test. So let me demonstrate really quick how this works. I've got a battery right here. Let me go ahead and plug this in. And so now we have a hot circuit now. See, the little light comes on. This will be connected to the ignition circuit on the car. So when the key's in the ignition, this little red light will come on to let you know that it's ready, if asked, to put on the choke. And so this right here is the switch that will go to the key. And you can see, look, these are very, very small wires, so they don't carry much amperage. And when you turn it on, whoops, just one activation, and the switch comes on. And I'll set a timer here. Let me take my watch off. You can see the timer, and we'll time it. The way that you control the way that this works, this has another method where you can have it so that it will cycle on and off and on and off. We're not going to do that. We're just going to run it in the single switch mode, and that's what this indicator right here is for, this little jumper switch. We have it in the MON state, not the cycle state. Without the cycle state, we don't need to worry about this switch. This is a little controller where you can turn and adjust the dead time between the cycles. And this controller here tells you how to adjust the time that it's on. And currently, I believe I have it set for 2 minutes. And so that's how that's going to work. We'll be able to hit the switch on the car. The little light will come on. It'll throw the solenoid into the on position. That will give you a rich mixture on my Weber. And then after a couple of minutes go by, you'll be able to see that it will turn itself off, and we don't have to worry about leaving it on and burning it up. And you know, it could basically just become an automatic choke, but the way this system works, you have to actually activate it in order for it to turn on. So that's kind of how this works. And let's see, we should be getting close to 2 minutes here. I've talked long enough. And so when it gets there, you'll be able to get to, there it goes, it just turned off. So there you go, just under 2 minutes. So another feature with this is, let's say for instance, I start the car and it's running fine. I don't really need the choke. Well, I don't want to have to wait for 2 minutes. So let's see, I'll turn it on. And you can see it's gone into on position. And if I want to turn the choke off again, I just hit the switch again. And it goes back on again. So you can turn it on, turn it off, and turn it on, turn it off, and you can turn on the detent at will. All right, so my intention was to have the wires coming out of the bottom of the box here, and then mount the box up. We've got it adjusted for our 2 minutes. I'm going to go ahead and put this together, and I'll put this in with a little bit of super glue so that it stays in position. We'll see if we get a little LED action out of that. All right, moving on to the next steps. All right, so quick review here. Now that I got this thing all wired up, ready to go into the car, you can see I've got little super glue holding in these optic lenses. I tested them on the bench. The red one's much brighter than the green one, so it's just going to be what it's going to be at this point. But you can see I've got one zip tie holding this thing together. The whole thing comes together. It's got a pin and a pin holding the circuit board on. The wires are as such. These blue wires are the signal wires. You can see the red, the kind of white. These were the key wires, as they called it on the diagram. But these are the signal wires, and these will go to the switch. That's why I kept them blue. They'll go to the switch in the dash. These, the black wire is ground. I've got a loop on there. It's going to go right on here when we screw it in. These two wires are together. The red one with the stripes on it. This one is the common wire, and then the red wire here is the load. And this will go to where the blue wire was on the signal side of the relay. So all of this is to replace the switch from the relay. So that's a good review, I think. I'm going to go ahead and put it in place, and then we'll do a quick test. All right, so we got it all reassembled and everything's all installed. Let's have a look and see how the operation works. First off, I'm going to put the key in the ignition, and you should see a red light come on. All right, there you go. Red light on. All right, that tells me that the system is ready to be used. So, with the ignition on, I'm going to flip the switch, and we're going to see that solenoid get triggered. There we go. All right, so the solenoid has activated. Now, what happened here is that this delay switch has turned on power to this line right here, which this is a relay, and that is running power from this red wire through to the output of this red wire, and that activates that. This is grounded directly to the engine block. And so 2 minutes later, you barely see the green light. The green light's lit right there, but you'll see when it turns itself off. In about 2 minutes, the whole thing will turn back off again. Now, hopefully, this eliminates that human error factor that I've been having, where I leave this device on and then it burns it up. I don't want to have to keep replacing those, so this little buffer will give me that ability. And with the DCOE, it's not necessarily a choke. Like I was saying, most chokes, it's a plate inside the throttle body that changes the vacuum pressure with the venturi, and it draws more fuel in to make the fuel richer and less air. In the case of the DCOE 45, the whole idea is unimpeded airflow. So it only has one throttle butterfly valve. And so when you want to run the choke, they have a circuit. It's a starting circuit. And what that does is it opens up another jet to allow more fuel to come in instead of changing the venturi to draw more fuel in. That's kind of how that works. So instead of having a big old cable, going through and then having a pull choke connected to this, I have this electric choke. All these wires, I'm going to clean those up and they'll be really dressed up nicely. Otherwise, heck, I might as well run a cable, right? But yeah, they're just in there for the initial test here, and then I'll dress them up and put some wire management on there. So there you go. 2 minutes have passed and it's turned itself off. Excellent. That's exactly the design that we're looking for, and that's the whole reasoning and the purpose behind this little modification. Then you can see the little green light's gone off and it's still red, saying that it's active to continue to run. Now, I don't know about you, but when I start a car, the choke is really only for rough starting. And hopefully 2 minutes is long enough for the car to warm up enough that I wouldn't need to choke anyway. So that's what I got for you this week. Make sure that you subscribe. I've got a whole bunch more projects I want to work on with this car and some other stuff around the garage. So if you have any questions at all on this project, make sure you throw them in the comments. Share my site with other folks so we can get other people in the community to see this wonderful car. That's all I got for you this week. Cheers.